Welcome to Byte-Sized Tutorials, where we break down complex topics into quick, easy to digest lessons.
Today we are diving into an important topic, rate limiting. If you've ever used an API and suddenly got a 429 2-minute request error, that was rate limiting in action. But why do APIs and servers need to limit requests? How does it work and where should it be implemented? Let's break it down. Imagine you run a web service and suddenly thousands of requests start coming in at once. Maybe it's a spike in legitimate users, or maybe it's an attacker trying to flood your server. Either way, without rate limiting, your system could slow down, crash, or become completely unusable. Rate limiting is the technique that helps control this flood of requests, making sure resources are shared fairly, preventing abuse, and keeping things running smoothly. There are several key reasons why rate limiting is so important. First, it prevents denial of service attacks. Attackers sometimes try to overwhelm a server with requests to bring it down, and rate limiting makes that much harder. Second, it helps manage resource usage. If one user or bot starts sending thousands of requests per second, your system could struggle to keep up, affecting everyone else. Rate limiting ensures no single user can hog all the resources. Third, it improves user experience. A well implemented rate limit ensures that your app stays responsive and fast for all users rather than slowing down under excessive load. And fourth, it can save you money. If your system runs on cloud infrastructure where each request costs you money, stopping unnecessary requests early on can significantly reduce your bills. So, how does rate limiting actually work? The most common method is to track requests over time and enforce a limit based on a defined window. For example, you might allow a user to make 100 requests per minute. If they exceed that, their requests could be blocked, delayed, or deprioritized until the next time window starts. But rate limiting isn't just about counting requests. Sometimes some systems apply limits based on bandwidth usage, ensuring that no single user consumes too much data while others restrict access to specific resources, like limiting login attempts to prevent brute force attacks. Now, where should rate limiting be applied? The best place to enforce rate limits is at the API gateway level. API gateways like AWS API Gateway, Kong, or Glue Gateway are designed to handle request limits before they even reach your backend, making them the most efficient option for large scale systems. Another good option is applying limits at the web server level using Nginx or Cloudflare. This is especially useful for websites where you can block scrapers, bots, or excessive login attempts before they reach your application. The last resort is applying rate limiting inside your application. While this can work for fine grained controls like setting different limits for different users, it's not ideal as a first line of defense because the request has already consumed CPU and memory by the time your app processes it. Different algorithms are used to enforce rate limits. One simple method is fixed window algorithm, which tracks requests in fixed time blocks. If you allow 100 requests per minute and a user reaches that limit, they're blocked until the next minute starts. The downside is that the users can send all 100 requests at the last second of the window, causing sudden traffic spikes. A better alternative is the sliding window algorithm, which smooths out request flow by continuously tracking requests over a rolling time frame. Then there's the token bucket algorithm, where each request consumes a token from a bucket that refills over time, allowing some bursts but still enforcing an overall limit. Another approach is the leaky bucket algorithm, which processes requests at a steady rate while queuing access requests instead of blocking them outright. Each of these methods has its own trade offs, and the right choice depends on your system's needs. To implement rate limiting effectively, start by setting fair limits. If your limits are too strict, legitimate users might be blocked. If they're too high, they won't be effective. Monitor your traffic patterns and adjust limits based on real world usage. If you're building an API, consider exposing headers like X rate limit remaining so users know how many requests they have left before hitting the limit. If you need flexibility, use dynamic rate limits, allowing higher limits for authenticated users or paid plans. Finally, combine rate limiting with other security measures like bot detection to protect your system against more advanced threats. And that's it. Rate limiting is a crucial tool for keeping APIs and servers fast, secure, and efficient. Whether you are running a small app or a large scale cloud service, implementing rate limits at the right place using the right strategy can make all the difference. If you found this helpful, don't forget to like, share, and subscribe for more bite sized tutorials. See you in the next one.